All right, I'm back and with sound now. So, where were we? Yes, we were going through the thing. This sequence is good. I think we can implement it. Yeah. So let's continue. Sorry. So cute. The definition path I'm passing is where is it exactly? The definition path, the message, the context path. And the way I had envisioned it is that I get a current value and I set the current value where it would be 11, right? Yeah. You have the add do's, so the add do, the leftmost add do becomes the value path and the target path we did that there. Let me just confirm that. Yeah, so the 11 is the context path. The value path is what you're calling it with, right? Yeah. And the value path is the one we're walking. That makes perfect sense. The target path is 11 equal. I would just do this on the actual because target path I'm adding the equal, that's why there's an equal. Okay. Yeah, good. Okay, that's good. So it's an 11. So we're here. The context path is where we are really setting things, right? So if we're gonna return a set of paths, we need to probably get stuff from there. Or maybe not. Let's see. Okay, let's do it. Where's the algorithm? So here we get the definition. We don't need the responses at all. We need to get, first we need to see what's already there. And I see that here you return the current value. Okay. Let's just think a little bit this thing. Okay, it's finally starting to feel easier. Here this current value will be a list of paths with with colon and perhaps equal, not more than that. Perhaps we can I'm writing down notes. I want to avoid having to copy part of what's there and just add more. I want to do, for example, to set, for example, colon sec2 to x rather than having to bring the entire thing back. Why does it do that? The entire thing back. Well, maybe I can just get the whole thing and just push it, right? Because if I have to overwrite things, because the current value is done on it's in the target path, which is this stuff, and equal. Yeah, this already won't work because I need to do it in a separate thing, unless the target path really becomes 11 in this case. Because I need to do colon and equal, right? Yeah. Yeah. It's silly. Not silly, it's just low level, but I have to fix this. How is it going to return these things? Once we have that out of the way, we're good. We can continue. Because here I'm just comparing the current value. So basically I have to compare two things here, not one. I have to compare colon and equal, right? And update either of those. unless cell.do directly calls puts. Do we want to do that? That would be quite daring. Would it help our intuition to know, okay, if there's expansions to be done? Rather than returning the value, we just let that one directly do it. Because the call to put will call again recursively all of the we call so respond on all of the lines. No, it's too much. But then if it's too much, how would you solve it? Then I would have to overwrite previous value on the entire thing. And also add the at. Yeah, I guess we could do that. And if I could do that directly. Why do we need that in the execution? I don't know why I need to add that conditional there. I want to get rid of it. Let's see. So I guess in some cases, like that one, yeah. Okay. So I need that conditional for the time being. Okay. So I have this. So if cell.do calls puts, if cell.do calls puts, what would it put? It would put stuff on the sequence. And then it will return the value of the equal. Oh, that's interesting. If we are executing, we do two things. Set update colon gradually and return a value for equal, which will be put by By whom? By the caller, which is cell respond. So, no, I'm not laughing. That's my wife. So, okay, let's just do this. We check what's there in colon. Wait, we might have to update what's there. If there's nothing, sure, but if there's something, we also have to put something. I'm leaning back towards returning the whole thing. Whatever is in 11, right? Whatever is at 11, return the whole thing, and then we compare. But then again, how do you know what you don't know? You have to still compare it inside here because you don't know you have to update it or not. So instead of doing that, just do it idempotently. Yeah, but how am I going to do it idempotently if I do this step by step? I can't. I will basically have to compare the first step, see that it matches, yeah, we can do a check. So we could do something like this. Because we have the context path, which is where we're setting things, right? Yeah. So get will be context path concat colon. Is it like that? No, yeah, the context path is nothing. Okay, I will throw away this code, but I'm gonna write it anyway. So I have this. So I have the definition now. How pretty, right? Perfect, good. Perfect, there's nothing. We would basically first compare but how would we know that things haven't updated? I know I'm jumping ahead, but we're gonna have that issue in 5 minutes afterwards we finish this one. How would I know if the thing changed or not? I might have 3 steps. So how do I know to continue or not? I would have to recalculate the whole thing every single time, but I can't because I'm doing just one at a time. You see my problem? I'm gonna write it down. so don't forget it. But how do we know if things changed? We would have to do the whole thing from scratch again. Well, maybe that's not a bad idea. Check that the message is the same. If so, move on. Check that the first step is the same minus expansions. Perhaps just the add. If it's the same, move on. If not, override and stop. So I guess you can do that. Just look at the path of the add, right? How do you know that the first is the first step of a sequence always a call? Yeah, it has to, right? I never validated that. I think I subestimated the difficulty of this. Is the first sequence, the first step of a sequence always a call? I would think so. How could it not be a call? Well, I could just put some constant there. That would be absolutely useless because you're not putting it anywhere. You had to use a put to actually put it somewhere, not just put it there. Technically, actually, that would be nice. You could actually, that's an interesting idea. Implicitly, you could say, put a hash on 1 or 2 and then reference it like so, like add colon, let's say 2 full. It might be better to give it a nicer name, but you could actually do that. You could do something like add do 1 super list full bar something else, and then you skip the output. Not bad. Yeah, I think it's unreasonable to forbid this. I would probably do it. So, how do we compare what we have to what is there if the step doesn't start with add, doesn't have an add in one of its paths. In the first step of one of its paths, compare it literally. Otherwise, compare just the at and ignore the rest, because those are and equal. Okay, but now make it more fun. How do you compare the part expansion? So, sorry, I know I'm skipping forward, but I don't want to implement something that then we cannot update properly. I need to deal with this problem. I need to leave in 1 minute. So how do you compare expansions? Just look at that 1 sec, and then we'll resume the next session. You will have something like this. So whatever is in the first step you'd have, but you have to filter out any paths that have equal, replacing an at, because you won't have that now because you haven't done your own expansion yet. You have to ignore the equals. This is an interesting pattern. Thank you for watching. I'll see you next session.